Hello students, welcome back to the class. Today we will see NCERT chapter 2 structure of atom exemplar questions. So there is an announcement regarding a mock test. So it will be held on 24th. So this coming 24th, day after tomorrow. So please attend that mock test so that you can get an idea how your preparation is going on. So it will be covering all the topics that I have taught you till now. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So here is your first question. So question is saying that which of the following conclusions could not be derived from the Rutherford's alpha scattering particle scattering experiment? Options are: most of the space in the atom is empty. Second is the radius of the atom is about 10 to the power minus 10 meter, while that of nucleus is 10 to the power minus 15 meter. Electron move around in a circular path of fixed energy called orbits. Electrons and nucleus are held together by electrostatic force of attraction. So I would suggest you to write the correct answer by yourself. Your time to solve this question starts now. Okay, so the time is up. What was the Rutherford's alpha scattering experiment? Remember, he radiated the gold foil with alpha particle and then he received the outcome with the help of a zinc sulfide panel. Okay, so there were conclusions of this Rutherford alpha scattering experiment. On the basis of that, he gave some postulates of his atomic model. So you have to identify that which postulate is not derived from his experiment. The correct answer will be 3. So he was not describing any energy about the electron. Okay, so he was telling that electrons are revolving around the nucleus, but he didn't talk of a fixed path or a fixed energy. So this was there in the Bohr's model. So what would be the solution for this question? If I try to explain it, then the idea of the circular path with a fixed energy was put forward by Bohr, as I told you, and it was never derived from the Rutherford's scattering experiment. Okay, so out of this large number of circular orbits theoretically possible around the nucleus, the electron revolves only in those orbits where the energy of value is fixed. Value of energy is fixed. So you have learned about it. It is called as the stationary state or the energy levels. Now, what about the options that we didn't choose? So these remaining options have a statement that is according to the Rutherford's alpha scattering experiment. So this was one of the statement that most of the space in the atom is empty. Yes, he said that because most of the particle went through the gold foil without any deflection. So it was clear that inside the gold foil atom there is very much space that is empty, and due to that the alpha particles were passing easily through them. Now next, this was also in his model in which he was describing the radius of the atom which is about 10 to the power minus 10 meter in the order of angstrom. Okay, while that of the nucleus was 10 to the power minus 15 meter. And the third one was the electron and nucleus are held together by the electrostatic force of attraction. Now this conclusion was also derived from the Rutherford experiment, and the deflection pattern of the alpha particle indicated that there are positively charged there is a positively charged nucleus and there are negatively charged electrons, and those are held together by the electrostatic force of attraction. I guess this question is clear to you. Moving on to the next question. So the next question is regarding the probability density plots of 1s and 2s. So I will suggest all of you to write the answer by yourself. The question is saying that the probability density plot of 1s and 2s orbital are given in these plots. So these are the two plots. You have already seen it. It is of 1s and 2s. Now the density of the dots in a region represents the probability density of finding the electron in the region. Now on the basis of this diagram, you have to select that which of the following statement is incorrect. Okay, remember you have to find the incorrect statement, not the correct one. First one is, first option is 1s and 2s orbital are spherical in shape. So this is the first statement. Second is the probability of finding the electron is maximum near the nucleus. Okay. Next is the probability of finding the electron at a given distance is equal in all direction. Fourth one is the probability density of electrons for 2s orbital decreases uniformly as distance from the nucleus increases. So what will be the correct answer? Any guesses? Your time to solve this question starts now. So this is a very good question because it is touching the concept of this probability density and kind of looking at its complexity, right? So any guesses for this question? You can just write it by yourself. So what will be the correct answer? The correct answer will be that the probability density for 2s orbital decreases uniformly as the distance from the nucleus increases. Now this statement is wrong. Why it is wrong? For that you have to look back at the plot that you got. Okay, so there was a plot for 1s and 2s. Was it uniform? No, it was not uniform at all. So what we can write in the solution part? So as we move for 1s orbital, the probability density is maximum at the nucleus. Okay, and then it decreases very sharply as we move away from it. Okay, very good. But what about the 2s orbital? If you look at this graph here, then you can see a region that is having a lighter portion in the middle. So it is first increasing, then it is decreasing in this middle part, and again it is increasing and then it goes on decreasing. So this region is not uniform, but in case of 1s, it is completely uniformly decreasing. There is no radial node. So due to the presence of the radial node in the 2s orbital, there is a non-uniform decrease in, or you can say a non-uniform change in the electron density. Is it clear to all of you? Any doubt in this question? Okay, let us move forward. Now next question. The number of radial nodes for 3p orbital is. So there are 4 options, 3, 4, 2 and 1. What will be the correct answer? You have some time to solve it. Your time starts now. So what will be the number of radial node in this question? Okay, very good. So let's see. What is the formula for calculating the radial node? You have to remember that because that is important. So the correct option is first of all 1. There will be one radial node. How we will solve it? So to solve this, you must know first of all the formula as I told earlier, and second the value of L and S for this given orbital. So this is your formula, n minus L minus 1. Okay. Then here n is your principal quantum number, L is your azimuthal quantum number. If you take 3p orbital, then in 3p orbital the value of the principal quantum number will be 3. Okay, n is equals to 3, it is the shell. Now what about the L value? So for p orbital it is 1, we know it. For s orbital it is 0, p orbital it is 1, d it is 2, and so on. Now put this values here in the given formula. You will get your number of radial node as 1. Okay. Moving on to the next question. So this is about angular nodes for the 4d orbital. So here in this question you have to count the number of angular nodes for the 4d orbital. So how you will count it? We will apply the formula simply. So you have some time to solve this question. Your time starts now. Okay, so 3 seconds more. What will be the correct answer? I guess it's an easy one to solve. The correct answer will be 2. So there will be two angular nodes. Okay. Remember students, you are counting the number of angular nodes. So what is the value of angular nodes? It is always equals to the value of L. So for the d orbital, the value of L is 2. Therefore the number of angular node is 2. Okay. If you are not able to solve it, no problem. It's very easy to understand, right? So once you remember that the number of angular nodes for any orbital is simply equals to the value of L, you will be easily able to solve it. So that same thing is applied here. Number of angular nodes is equals to L, which is L is the azimuthal quantum number. And for 4d orbital, the value of L is 2. Therefore, the number of angular nodes is also 2. I guess it is clear to all of you. Any doubt in this question? Now moving on further. Next question, for the electrons of oxygen atom, which of the following statements is correct? Your options are A. Z effective for an electron in a 2s orbital is same as the Z effective for an electron in a 2p orbital. Second one, an electron in the 2s orbital has the same energy as the electron in the 2p orbital. Third option, Z effective of an electron in 1s orbital is same as the Z effective of an electron in 2s orbital. Then the fourth one, the two electrons present in the 2s orbital have a spin quantum number ms but of opposite spin sign. So it's a very good question. Your time to solve this question starts now. So if you know it, you know it because it's a theoretical question. So let us see what is correct. The correct statement will be the fourth one. Okay. So it is easy to find the correct statement in this question rather than buzzing around other options. So you know it very well that in a given orbital, if there are two electrons, they will always have the opposite sign. Okay, so that thing is written here. So therefore, this statement is correct. You know it very well. If you are filling a orbital, then in that case, you will fill them in the way that they have the opposite signs. Okay, if they're in the same orbital, you have to fill them in the way that they have the opposite sign. If one is plus half, the second will be minus half, and the vice versa is also true. Now, how we will look onto the other statement, that is important. Okay, before that, let us look at the correct one. So one will have plus half and the other will have minus half. Therefore, both will have different spin. Now we'll deal with each and every statement one by one. If you have a doubt, please ask it. So first is, the electron in 2s and 2p orbitals have different screening effects. Okay, and due to this reason, the Z effective is different for 2s and 2p. In fact, the value of Z effective for 2s is greater than the value of Z effective for 2p. Therefore, the first statement is wrong. Did you get my point? So we have studied in the previous class that the penetration effect, remember the penetration effect? So the penetration effect of S is greater than the penetration effect of P. As a result of that, so penetration means how deeper the electron is going. Now, as a result of greater penetration effect of the S orbital, it will remain closer to the nucleus, and hence this Z effective, which is simply the force that is applied onto the orbital, increases because of its closer vicinity. Is this point clear to all of you? Now moving on to the next point. So it was given that the energy of 2s and 2p orbital is same. Now this is also incorrect, because if your 2s orbital is experiencing more Z effective, or you can say it is experiencing more attractive force, therefore its energy will decrease. As a result, the energy of 2s orbital will be lower than the energy of 2p orbital. Their energy can never be same. Now we have also seen this thing also, that if you are given the same principal quantum number, then in that given quantum number, the energy of orbital increases in the way that S has the lowest energy, then comes your P, then D, and then F. So these questions are all from the filling up of orbital, which is section 2.6.3 from NCERT. What was the last statement? That the Z effective of 1s orbital and 2s orbital are equal. Okay, so this was the last statement. So again, 1s, and if you compare 1s and 2s, 1s is a orbital that is present in the first principal quantum number. Now you know it very well that as we go on increasing the value of principal quantum number, which is here increasing from 1 to 2, its size increases. So if the size of the orbit is increasing, the size of its orbital will also increase. Okay, and hence the Z effective for 1s will be always greater as compared to the Z effective of 2s. Now you can think it of in another way also, that since your 1s is coming first, or just after the nucleus you have the 1s, and after that you have the 2s. So 1s is coming first, so it will experience a direct force from the nucleus, whereas the 2s is present behind it, so there will be a shielding effect. The 1s will shield the 2s, and as a result it will experience a less force. So we can say that Z effective of 1s is greater than the Z effective of 2s. Okay, now let us move forward. Next is, if traveling at same speeds, which of the following matter wave have the shortest wavelength? Okay, so you have to look upon the wavelength. Remember, this is from the de Broglie part. Your four options are there: electron, alpha particle, which is simply helium 2 plus particle. We have already talked about it. Then comes the neutron, and lastly comes the proton. So what will be the correct answer? Just write it by yourself. The time to solve this question starts now. Remember the de Broglie relation between the wavelength and the mass. Okay, your time is up. Let us see. So the correct answer will be alpha particle. Very good. It will be alpha particle, which is option number 2. Now how we will solve it? We know it from the de Broglie equation that lambda is equals to h by mb. Now we can clearly see that lambda is inversely proportional to the mass. Now, if I ask you that which has the least mass of all, then what will be your answer? Or which one will have the greatest wavelength? So I am leaving this question on to you. Then if you compare all of this, then the electron, yes, the electron will have the smallest mass and it will have the greatest wavelength. Then comes your proton, okay, and proton and neutron are having approximately same mass, so they will have approximately same wavelength. And lastly comes your alpha particle, which has the mass of 2 proton and 1 electron. Now we can neglect electron, so we can say that it has a mass of 2 proton. So clearly it will have a what? It will have a smaller wavelength. So this is directly coming from the relation that lambda is inversely proportional to 1 by m. And as a result, since your h is constant, okay, and it is also given that they are traveling at the same speed, so velocity is also constant. Therefore, the helium-2 plus, which has the highest mass, it will have the shortest wavelength. And also remember that the electron has the least mass, so it will have the greatest wavelength or the longest wavelength. Our next question: arrange S, P and D subshell of a shell in the increasing order of effective nuclear charge experienced by the electron in them. So this is an objective type. How you will rearrange it? Just write it in the copy by yourself. Now you have some time to write it. What you have to do, you have to arrange the SPD subshell in the increasing order of effective nuclear charge. So this is a short answer type question from NCERT Exemplar. Okay. So let us see what is the correct answer. So it will be in the one line. So we know it very well that s orbital is spherical in shape. Okay, so here we are talking about the effective nuclear charge, right? We are not talking about the energy. You have to say that which one will experience the greatest nuclear charge. I've already told you. We have to consider S, P, D and F. Okay. Now, we know it very well that your s orbital is closest to the nucleus. Okay, and as a result, it will experience the maximum effective nuclear charge. So I guess you are confused about the energy and effective nuclear charge. So if your energy was decreasing, means s orbital was having the least energy, it means it was experiencing the greatest force. I am again repeating the very important statement that since your s orbital is having the least energy, it means it was experiencing the greatest attraction force due to the effective nuclear charge, and as a result its energy was decreasing. So if I say this, then we can write the order as greatest for S, then comes your P, and lastly comes your D. In the next question, you have to see that according to the de Broglie, matter should exhibit dual behavior, that is both particle and wave like property. However, a cricket ball of mass 100 gram does not move like a wave. Okay, so when it is thrown by a bowler at a speed of 100 km per hour, calculate the wavelength of the ball and explain why it doesn't show wave nature. So just first of all calculate the wavelength related to this ball, and then we will see that why it is not relevant for the ball. Your time to solve this question starts now. The time is up. Okay. Yes, due to the huge mass. We will see what is the correct answer. So first of all, it is given in the question that mass is 100 gram. So we are converting it in the SI unit. We will write it as 0.1 kg. Second thing is the conversion of velocity into standard unit. So to convert kilometer into meter, we multiply it by 1000, and to convert hour, we multiply to the minute, to the second, we multiply it twice by the 60. Okay. Any doubt in this? Why are we multiplying this? Because 1 hour is in the denominator. So to convert this thing into seconds, we have to multiply twice with the 60. Now, if I calculate this, you will get it as 1000 by 36 meter per second. So if you put all these values of mass and velocity of the ball in the de Broglie equation, which is lambda is equals to h by mv, you will get your wavelength as 238.5 into 10 to the power minus 36 meter. Okay. Now you can see very clearly that this wavelength is very small. Okay. And as a result of this, the wave nature of this cannot be detected. So this is all about the NCERT Exemplar.